schedule, so exam will be 8 a.m. Unfortunately, it's 8 a.m. To the 10 a.m. So May 5th is a Thursday. Don't forget the time and the date. The issue is we cannot find the bigger room like the midterm exam. So I'm still looking for another room. If I can do that, I'd like to separate into the two groups of this exam, because I don't think this room will be enough to have a final exam. But in worst case, I'd like to use this room or to find another available room. And sometimes student, either professor will do the final exam earlier or later, so not assigned the date. So, but we are going to have the final exam on the date. Oops. So, unless I notify the new location of the final exam, the exam will be this room. So please come to this room on Thursday, the 10 a.m. The coverage will be after the midterm exam, which will be chapter 7 through the chapter 13. Okay, and I'm not sure whether we can discuss more topics after we finish the chapter 13. But even though we discuss about another topics, the final exam will be chapter 7 through the chapter 13. And also this Thursday, we are going to have the final exercise lab. Also, I strongly suggest you to attend the engineering colloquium on Thursday. This time, we have a guest speaker from the National Science Foundation, who is the program director of the cybersecurity scholarship and related stuff, but he is also the professor in the Penn State University regarding to the information retrieval and data analytics. So this will be very interesting topic and the presentation I suggest. So probably on Thursday I'm going to post to the speaker. So, but I guarantee we will have the quiz. Before we have the final exercise lab. So please attend the class on Thursday. So hopefully I would like to finish chapter 12 today. Okay. And also I already made a quiz for the chapter 11. So in the middle of today's class we will have another quiz. One couple of students asked me whether we can get the quiz for studying, but there's no functionality to export the food. Otherwise, I need to type everything again. So all the question is from the slide only. Okay, I do not make the harder or anything changes. So it's from the slide. So I don't think you need to study only for such a quiz. It's just for your video and attendance check. As I said, the quiz, pop-up quiz, the homework quiz will be the take-home quiz. The online quiz will be the part of the regular, the final grade. But this one, the pop-up quiz will be just the extra point. In addition to your final, after I finalize your grade, 100 scale, then I will add your point to those who participated in the quiz and get the score. Any question regarding to the schedule of the rest of the semester? And also the GA will assign the demonstration for your project. Please attend. Unfortunately, we do not have a time to, but if the GA finish all the demonstration and grade on time, so I would like to ask the GA to select the group, the implementation and the result of your project, and we'll maybe next week we will ask the students who are selected to demonstrate voluntarily. Those who demonstrate will get also extra point. Okay. So chapter 12, so based on the chapter 11, the file system interface. So we are going to discuss about how to implement such a file system. Last time I quickly go over the file system structure. Anyway, the file system is also software, which means means whenever you implement any kind of software, the the starting point is structure. Okay, you need to design. Think about the object-oriented programming. You need to design the problem. Okay, in terms of object-oriented concept. So you design the class. Class. What is a class? Class is actually nothing but it's a data structure. That data structure includes your data type as well as the behavior, operation, or some method. Okay. Any software, the computer-related stuff is, I believe, is nothing but the data structure. So depending on your objective or the goal or the subject, it can be a different data structure, but anyway, it's related to the data structure. Same thing for the file system. File system is the software part of the operating system. So we need something data structure to keep what? The information as a file format, and since we have a lot of files, so we are going to consider the enhance the data structure to keep such a number of files. So how can we keep such a file? Using the file control block, just like you define the process control block PCB when we manage the number of processes. So we are going to define such a file control block. So if we just suppose you are going to implement a file system. So first you need to design what is a file structure. Are you going to use a general file structure or the specific purpose of the file structure? Then after that, you need to define what kind of information, metadata information for each file to match the number of files that will be implemented as the data structure of the file control block that includes every information of the file. Okay? So when we design the file system, the most popular approach is the layered approach. I don't know what other. The other probably put all together, centralized everything. If your file system is just a simple portable file system that will be implemented based on the existing file system, you don't have to worry about this, part. You can implement only the application program or logical file system. So, but most popular approach is such a layered file system approach. This is a hardware part, this is a software part. This is your program, this is the hard disk drive or solid state disk, any secondary storage. Therefore, you can keep physically keep the files. So, from the application program, so like the C program or C++, Java program, any program, so when you need to access the data information from the file, request such a file. There's a logical address as we discussed before. Then there is a logical file system that includes the file control block. Not directly access the file in the hard disk drive or the hardware. Instead, first, we will discuss more about how to manage a number of file control block. It will be the two approach. One is the per process. So each process need to use the file. So each process will manage a number of file control block that are accessed, that are opened, that are managed. And also another approach is another group is the system-wide. In the operating system-wide, which files are accessed and which files are used. There are two locks you need to consider as we discussed before. One is a shared lock, a number of processes can read the file, and another one is the exclusive lock, the write lock. So when you write the data or when you modify the data, only one process can access the data that will be managed in the logical file system. Then the next one is when you decide which file you are going to access from the logical file system and update any the information or permission, whatever, then you need to the information about the logical block and the physical block. You remember that most of the operating system and application, when they read and write the data, it will be based on the block. Okay, block by block. Even though the block size depends on the operating system used mostly the 512 byte, the block size. So, which means even though you need only 1 byte of the data, entire block that includes the information requested will be returned. Okay, or if you have the 1 megabyte, 1 gigabyte of the file, it will not be the return altogether. It's a block by block. Nowadays, such a block size is various. So especially for the big data system. Oh, by the way, in the morning I got the email, it's advertised email from the Oracle. Oracle from time to time they send not only for the Oracle, but not only by the Oracle, many of the IT survey company or the such educational the company, the institution, they make the which skill are needed for the IT job nowadays. Something like that. In 2016, the Oracle survey the 10 most popular or desired IT skill. So then do you know which one is the top skill? So IT architect, something like that, which means it's just an overview of your enterprise level, the IT environment, like the framework or software framework, hardware framework, or the application group of the application, ERP, so all of the things. So definitely the entry level of the IT architect is not easy. So it's required some junior, at least the junior level the experience. So, but among the 10, there's no skill directly for the operating system, but many of them are related to definitely it includes web development or the programming, the skill. This is a tradition, it's an obvious thing. Then there are several the new, it's not the new, but one is the business intelligence as well as the analytics skill. That's also very popular nowadays when you search the job. And another one is cloud, the computing as a service. Any application as a service based on the cloud computing. So that is, you probably heard about that. And another interesting thing is big data and the database administrator, which are required. It's a popular skill in the IT job market. But I believe that whenever I have been asked to increase the experience of such a skill, what do I need to do? So can you suggest any subject? At the time, some suggest to study operating system as well as computer architecture, and also if needed, networks. Okay, these are also core courses in the computer science. You don't have to study directly data to be a database administrator. Okay, you can catch up, but before that, you should have the general knowledge of the computer science. That's more important. When I learned the database administrator, I was lucky when I was hired. I directly assigned to the database administrator, even though I didn't have any experience at the time. The only reason, my major, and the major was mathematics. So the supervisors pick me up as a database administrator because I majored in the mathematics. So he believed I can catch up easily. Partially is true. So then the most difficult part when I learned the database administrator start or the database, the relational database, is I didn't have background in operating system and networks. So whenever we have a meeting in the system at the department, so it's very hard to argue. I believed, so this one is correct, but it's very hard to support my idea without knowledge. So that's such the basic subject. So please, the operating system is still, I believe, the very important the subject. So also, if you get the degree of the computer science, master level degree, and also if you wanna survive around the IT, the industry for your life, I strongly suggest to have at least one textbook, please. So I know you can get the most of the such information from the Google or Wikipedia, but I strongly suggest to have at least one. It doesn't have to be our textbook. Any the operating system textbook, they are good, and it's just way the summarize the preset, have such a textbook for you. Anyway, so keep going with the layered file system. That is the file organization module. It has the information about the logical, the block, and the physical block. Using that block information, it can be converted to the hardware, in terms of hardware perspective, the location of the block, physical block. For example, drive number HD0, HDD, one something like a cylinder number, drum number, and sector number. Then you can that is the map to the physical block number. Okay. Then finally, using the device driver, which is in the controller. Any hardware device connected to the computer should be connected via controller. Okay, so that controller has the device program, the device driver. That device driver, using this information where the data is located. So, for example, in case of a hard disk drive, so it has the seek time and rotational latency. Then finally, it will return the data, that is the hardware instruction, but where it goes. When you find the instruction, it will be informed to the device driver, controller, internal, the operating systems, and the signal to the operating system. I'm ready to return the information, instruction that you requested. Then it will be moved to the memory. Then finally, operating system can access the CPU can access such a hardware instruction or data from the memory. Okay. Not always the file system use such all the layer in when they implemented. Some of the file system will be based on the existing file system from the file organization module to device. So on top of that, you can implement it. And even sometimes you can use the directly application level. So you can use existing the file system entirely. Then on top of that, you can implement the file system. There are a bunch of some of them ignore the block directly access the low device. Okay, so it may be possible. So these are the general approach of implementing the file system. So the next two slides explain about that we already discussed. Okay, so it's the opposite way from the device level to the application level, the logical file system, and so on. Okay. So there are a bunch of the file systems. So most popular one in the Linux and the Linux system is the EST, as you know, the EST2, EST3, and EST something. And the Windows has FAT, FAT32, and we will see such a basic file system today. It depends on how to allocate the block, okay, how to manage the block. So blocking is a very important concept to understand the I/O and to understand the file system, to understand the memory. So it's a very important concept, but many students ignore such a blocking. So we will see the FAT today and NTFS. In addition to such a popular file system nowadays, the new file system is coming out, such as the Google file system, Oracle ASM. It's called automatic storage management. This one is for the part of the long-time project of the Oracle. Oracle actually would like to. It is true when you join any IT group or IT department. So there are group of servers that is only for database. Okay, this computer, this server used for the database, and you have a number. This one is for the application server, like the web server or transaction server. This one is for business analytics or data warehousing. Each computer has their own characteristic. So for example, the database, I have a database server, which means you need to purchase the server hardware and operating system. On top of that, you need to install, for example, Oracle. Then sometimes, because of the operating system or hardware, especially operating system,
error or something problem. So you need to work with the operating system administrator or the vendor like the Sun Microsystem or the Microsoft. So they actually toss each other the problem, very hard to manage. Also, not all the functionality of the operating system are used when you install the database or when you manage the database server. So why don't we throw away the operating system instead? Because database is, even though database is application level, okay, running on top of the operating system, like what is this?
Computer.
This is a computer. Okay, so we have the operating system. Then inside the operating system, then we can run the, for example, Oracle. This is the only major application running on this operating system. And also, this Oracle, somebody says Oracle, the DBMS, Database Management System, is kind of in between the application, program, and operating system. Why? What is the main job of the operating system? It's a resource allocator and resource coordinator in between hardware and user. DBMS actually directly access the hard disk drive as a low device, not cooked device, not file system. You don't need such a layer, instead directly access the hard disk drive. Okay? So with the basic file system, by skipping the disk part, which means that this DBMS has a functionality of the file system. Also, sometimes the application DBMS directly control the CPU processor. Okay, using for example, Oracle, the application program, 80% of the code is C or C++. The other 20% directly assembly code, 20 to 30%, which means so it has some low-level coding. So what if we throw away operating system and include this one? It's the OS plus the DBMS. So DBMS, Database Operating System. So Oracle actually already tried to develop such the operating system, the DBMS, Database Operating System, but it's afraid. So because of the operating system has the older mechanism to the hardware, but the Oracle cannot address the support all the different the combination or whatever. So it's just, but still some of the approach remained. One of them is the Oracle the automatic storage management. That replace, they don't need the file system. Instead, directly manage the such a file system. Another popular newbies in the file system is the big data, the distributed file system, starting from the Google file system and HDFS, Hadoop distributed file system, which is based on the Google file system, and that there are more. So why don't you focus on such a interesting is that the Google file system or the big data file system is running on top of existing file system. So for example, if you are using the EST3, so you can still use the EST3, such as the big data file system, distributed file system will be installed on top of such an existing file system. Okay? So that is a new trend of the. So we are going to see the details of how to implement the file system. First one is in the file system operating system, the kernel module will be stored. So as we have seen the beginning of this class, so when you turn on the computer, so we already discussed what happened. One of the important thing is the computer system should know where is the booting the part, okay? And even the file system, so based on the hardware, the file system has the information about in case this file system has the operating system module, so they should know where is the kernel module that will be stored at the boot control block. Okay, so this boot control block has the location of each volume, like the C drive or the D drive, the E drive. Each drive has something master information, which is called the superware or the master file. The record MBR, master boot record. So this information will be when you design your file system, you need to consider such the boot controller and the volume controller. It's not huge, okay, but it's usually the beginning of your file system. As we have discussed a lot, the file system will be based on a number of the blocks. Okay, it's a logical block, and each logical block will be matched to the physical block, and it's a logical file system will map this the logical block, and each block, the most of the block will be used for the file block, but the beginning of the block it will be used for the boot control block or the volume control block. So because of that, if you damage or the crash for the such a block, you cannot access it. So it's called the super block. So you need to keep such information. Not all the file has the boot control block, but volume control block, each volume drive has the master information, like how many blocks it has, how many free blocks it has. So this is the volume control block. Okay, and that volume control block, the super block, has the information about the file, not directly access the file. So your file will be stored up here. And this file is a.txt file, all the metadata information, like the file size and the signing of this block, okay? And when it's created, what is the file name, what is the ID, will be stored at the such a master of the super block, okay? So that super block, when they manage the information about this file, will be the FCD or the a.txt file. Okay, so in other words, when you create the file system, so this master didn't have the project to implement the file system, but from time to time I referred to this one. It's not very complicated one, but the most of students are struggling how to start to implement. If you are asked to implement the file system, so on top of so for example, you are not going to implement all this layer on top of the file organization module. If you need to implement the logical file system and application level file system using existing. So you have, for example, NTFS. On top of NTFS, you implement the file system. So this is the actual file from the NTFS point of view, like the tested the FS file. It's just nothing but byte string, okay? Nothing else, just a byte string. So you can have for example, initial size is 1 megabyte. So you have 1 megabyte. Then you need to allocate the super block header of the file system. So like the 10 blocks. So you need to decide what is the block size, like the 512 byte. Okay? Then you know the how many block, number of block divided by this one. Using the such a block size and the block ID, you can actually locate, access each block easily. Then you define a number of block, beginning of the block as a super block. Super block include such a FCB. Is there anyone who are taking the database course right now? Only one? So second, task 2 will be based on this one. So that's the reason I expect that most of the students in the database class took the operating system, so I assigned the test 2, but most of the students didn't take the operating system. Probably struggling, but idea is this one. You can, then it's the same thing. In the memory, so you don't have to worry about where the index node. We don't have to discuss the details here. Okay. Anyway, so then this FCB will be created, located in the superblock. Okay. Then which means you need to define this one. So what kind of information I include? Any information regarding to the metadata information about your file, like the file permission, file date, who is the owner, and also its security reason, and file size is also very important. Okay, if somebody change the file, like infected by the virus, so you need to check. And block, where is the starting of the block? So then, or you can locate you can read the data from here. So that is file control block. Okay. Then when you open the file, which means so using the file system. So when we have the FCB of the a.txt, so I'd like to create, okay, open the file from the process. There is a process 1, okay, process would like to open using the Apple open, where in general just open the system library. So what happened? So this had of FCB information about the a.txt should be managed in the memory. So that is called in-memory file system structure. Why? For better performance. Okay, so let's take a look at this slide. So when you open the file in the kernel memory, so it has the, so for example, when you have the directory structure, okay, directory means in the your superblock, so you have the a number of files will be managed dir1, okay, dir1. So data structure of the directory we already discussed in the last class, in the chapter 11, using that operation and the structure we can implement such a dir. Okay, that dir structure will be in the memory. Okay, then the node where is the file control block of this one a.txt. Okay, then also the directory structure is in the FCB. For better performance, it will be copied to the memory structure. So in the memory structure, it has the information about the a.txt. Then when you read the data, okay, from the file, okay, when you read the data file, so there are, as I said, the two management. One is the system-wide, the open file table, which process is accessing or writing the specific file, which means the file control block, and the per process. For each process, each files are open. Okay, so two structures are managed when you read. This is when you read the data from the file. Okay, then finally, you should be able to access the data block. Here, we don't have to access because it's just open. This one is the read. So this is the memory, in-memory file system structure for better performance. What if when you close this system-wide, you need to reduce in case of a shared lock, reduce. You don't have to return in case that current process is the only process to access this data, this file, you can return, okay, the file control block, which means remove the information otherwise and update the information. And if your current process is access only this file only and the closed, then you can remove the purpose of open file table, otherwise update this one. Then this file control block will be removed from the list. Okay. And directory structure is also updated. Then another thing is the patch partition is the volume. So it's a logical partition. So even though we have the one hard disk drive, logically you can partition, divide into the several group that is called the partition or the volume, like the C drive or D drive, E drive, or in the Linux system you can have the mount point. Okay. I'm going to skip this part. And so based on such a data structure and the implementation of the file system, we have a number of different file systems in one operating system, like this one. So this is an example. We have the CD-ROM and the network file system and the ext2, and we have many different file systems as we have seen. Then how can you cut? Each file system has their own unit. Sometimes their own the API, their own the command or the command. So each file system has different implementation. So when you copy the data from one file system to another file system, how can you? If operating system does not know all the data structure and implementation of the file system, like the EST and NTFS, one of the good example is long time ago when I installed the Linux, and this is Windows. Right now we can use the virtual machine. Okay, virtual machine is in charge of all everything for the interface between the two different. So, but long time ago, so when I installed the operating system using the anti-loader, something like that, we cannot run this way. But when I boot Windows, but still there exists the Linux file system. But I try to access the file that I created in another file system. Because of the difference, this one is ext and this one is used the FAT. So 32, we cannot read it. So there are processes to connect this one. It was a Samba. So Samba program actually understand both of them, and finally you can read the data. Similar approach when we have the different file system. So why don't we have the virtual file system? Virtual is not file system, it's a kind of interface that can understand the file system 1, file system 2, file system 3, like including the NFS. So whenever you copy and read the data like between and different file system, this virtual file system interface will be used. So this virtual file system understand each and every the file system interface like this one. So it has the general standard, the API, like the open, close, read, write, the memory map, and so on. So then each file system has their own, maybe the same functionality but different name. Okay, the different library will be connected using the virtual file system interface. Some kind of interface, not the file system. That's the reason it's called the virtual file system. Okay, the next topic is what time is it? I'm going to continue. Okay, and if I finish on time, we will have to quit. Okay. After I finish the chapter 12. Okay. Then the next one is the directory implementation. So directory is a function to manage a number of files, and thus it will be located in the superblock. Also, the beginning of your file, the volume file system, the file system for the volume. Okay, that can be managed by the different. The most popular one is just linear. So a number of FCD of the files will be managed linearly, and also it can be something other indexing data structure can be used. Okay, so FAT used B+3. I'm not sure, I couldn't check it, but the textbook said so they use the they can use the B+3 in the FAT. the other references, but I cannot find. But it may be possible, I think, that when we have a number of files, okay, then the files will have the FCB. So this FCB can be managed by the tree structure instead of the linear list. So FAT is better to use such a B plus 3. So that is the reason some of the textbook mentioned the FAT theory to use the IDBMS. But I don't think it's the IDBMS. If this one is true, maybe the B plus 3 is used for to manage the number of the FCBS.
FAT32 doesn't use B plus 3. It's only NTFS and
up to the NTFS?
Yeah, NTFS that uses B
Yeah,
plus 3.
but I heard that, but I cannot find any reference.
It's actually available in the FAT-X as well. It's not available in FAT.
Okay. So that is, but that doesn't mean I don't think it's such a file system use IDBMS. Some of the articles says IDBMS, but the B plus 3 maybe used, it might be no problem. Also, another approach is we can use the hash table. So using the hash function, so usually the hash function provides very fast accessing the data. Ideal is we can narrow down the search, so using the hash key. The problem, as happened in the hash-based approach, it has a collision problem, so which means the different, the file FCB may be in the same location. So there are several approaches to address this one, okay? Like the hash of a hash or the extent of a hash or the linked list of the collision, collide the FCB. Okay, so next topic is so this is the logical file system. We have the logical number of blocks. Okay, then we have the file a.txt file. So I try to open the a.txt. It doesn't have to be only the full layer, the file system. So you can imagine the a.txt file is already exists on the NTFS. So this file system is running on top of the NTFS. It's like the file system name is the test.fs. So I'd like to move this a.txt to this one, open the file. Or you can create on the file system like a touch command in the Linux. So we have to create the file in the file system. At that time, we need create the FCB of the disk on the superblock. Also, another important thing is we need to allocate the space. Space means logical block. So you need to allocate the logical block to this one. So depending on how to allocate the number of blocks when you create the file, okay, there are different methods. So navigate contiguous. So if we can find the free block, so this file needs the 5 blocks. Okay, then we have to find 5 continuous 1, 2, 3, 4, 5. 5 continuous block, then allocate. Then this block number is over 200. 200 will be updated on the FCB. So that is a continuous approach. Okay, so now wait. Okay. It's so simple. Right? As long as you can find the continuous block, it's so simple. Problem, it may be the fragmentation issue. So you cannot, even though you have a free block in the file system, if you cannot find the contiguous block that can keep the file size, so you cannot create, you cannot open the file. So that is the issue. Overall, it's the best performance because it's a contiguous. So you don't have to implement any of those. If you can locate the beginning of the block, okay, then we can next. That's it. So overall, it's the best performance and easy to implement. So many of the cases when you create the file system, simple file system, you can use the continuous of the allocation method. So this one shows the example. contiguous in the directory, in the superblock directory structure. This is the number of file, as we have seen before. The directory structure keeps the information about the number of file. So using the FCD information, it shows only the block information, where is the starting. So, for example, count is start at 0. How can you locate this one? Block 0. Block size times block number. Okay? For example, 0, 512 byte is a 0 byte. Okay? If so. So using the simple math, you can actually easily locate the file location. Then the length, to make sure what's the size of the file, the length will be the 2 means the 2 block, so it will end block number 1. Similarly, for example, the list is starting from 28, it has 4 block, 9, 30, 31, and so on. So we can easily implement this one. And another approach, because it's overall the performance and easy to implement problem when you need to manage the number of the contiguous block, okay, which one is available here. Okay, for example, if you need to create the file, you need to search the 5 contiguous block, 5 contiguous block. Okay, instead, why don't we, instead of the block by block, the free space, this is a file system. So, 2, 3, 4, 5. So 5 free block, 5 free block, 5 free block. So certain number of contiguous block, not big, not too small, the proper size of the contiguous block. Then this is called extend. Extend is used a lot in any storage management application, including database. So database actually allocate the, probably if you are taking the, or if you are going to take the database also use the block by block, so we count. But in the real application, real DBMS, they allocate extend. Extend is number of contiguous block. Okay, like a 5. You can actually specify. So benefit, we don't have to, but if we have such a non-contiguous the allocation, we can maximize the utilization. However, whenever you access this one, you need to calculate the location address. So it's an overhead when you access millions of blocks. So millions of calculation are needed. So it's kind of an average in between the contiguous and the non-linear, non-contiguous approaches. So like the 5 blocks, extend 1, extend 2, extend by extend. You can allocate. For example, if the file size is 10 blocks, you can allocate from 2 extend. Okay, you don't have to find the 10 contiguous blocks. So that is called the extend-based approach. Extend-based approach practically used a lot for the storage management, including file system and the database system. Okay. Another approach is the non-linear approach. As I showed you before, non-linear approach is that you have only the starting. Okay, then each block has the next. Point the next. This one has the next, and this one is the next. This one is the next. Finally, if this is the last one, then return to the point to the directory. Okay, so like this in the directory. So start is the 9. So starting from the 9, then next one is the 9 has the, so each block has the 4 byte of the point. Okay, so this one point next is the 9 point, the 16.1, and so on. Benefit first, maximize the utilization. We don't have to find the chunk of the free space. So we can, as long as we have a free block list, and we can allocate as many blocks as possible until problem, as long as we have the enough number of free blocks. Problem, performance. Each time we need to calculate, okay? We need to calculate the next location, next location, next location. Last one is so null minus 1 is that's the end. So in the directory you can manage the start and end. So another problem, it's not a big problem, but for example, 512 write the block, 4 byte used for the pointer, which means 1% of the data is you cannot use it for the data. It will be used for the pointer. So it's the utilization slightly less than the contiguous approach. So that is the linked allocation. Okay, that's discussed in this slide. At around less than 1% of the utilization will be reduced. Okay, FIT used this kind of approach. So file allocation table used this one. So if we take a look at this slide, this is the overview architecture of the file allocation table. That is FAT 1632. So as you can see, the directory structure is a starting block, and going to next. And so how to address such a sketch-out problem? Defragmentation. So if you have used it before the Windows 95, 98, so from time to time it is suggested to learn defragmentation. Okay, defragmentation, because when our file size is bigger and bigger and bigger, which means we have more and more block, more and more linked. So when you access the data, sometimes it takes a whole time. So you need to start from here and next and next and next. Okay, so how can we speed up? How can we avoid such an issue? So put together next to each other. So that is the defragmentation. Okay, so that is the idea of the FAT. Okay. Then to access this is the logical file. Okay, so 1, 0, 1, 2. So my data is I got access to this, the instruction move. Okay, to access this one, you need to start from the first block. Next block is 680, 18, and then next, how many IO? 1, 2, 3 IO. Okay, 1, 2, 3, 4. 4 IOs are needed to access only one. So it's not, in terms of performance, it's not so good. How can we address that one? We can use the indexing technique. So which means, why don't we have the indexed block? Indexed block has this one. Then somewhere in your file system has used for the index block. This index block has a 0 is the 217. The block number 1, logical block number 1, this one is in the 618. And the logical number block 2 is a 339. So when you access the data in this block, directly go to 339, the pointer. This is called the indexed allocation. So to do that, we need to use a number of the blocks for the indexing. So this indexing block has the location of each file. When you access the file information, when you access the data in the file, you need to first go to the directory. So 1 IO, then using the index block. 2 IO, then using the index block, you have the location 3. So in this case, so this is the benefit of indexed allocation. Benefit? Faster. Faster than the linked or the non-linear approach. Problem? Not a problem. Any the cons, the issues? Oh yes, that's the one issue. So if we lose this one, you will lose. This is the point of failure. Another, it will be overhead to manage the index. What if we have huge file, like the 1 terabyte size of file? We need to manage a number of the blocks in the index block it will take a time to search in the indexed block. Right? So that is the issue. So how can we address? If you are taking, because I'm teaching the database also, first, the simple approach of the indexing is a single level index. So we can make the index. But if this index is so big, like in this case, so this one has only the 1, 2, 3, 4, 5 blocks. Okay, the others are -1, which means it will be allocated like this extend. So 8 blocks extend. So even though it's not used, so it will be allocated. For this, it's a -1. So what if it's too big? So we can have index of index as a user. So we have the index of index. So this is a directory structure. Directory structure. Find a number of our index block. Using that information, we can find the index block. So using the index block, finally, the find. This is not separated. Actually, all of these are in this file system. Okay. Some of the students confused. It's a separate. No. This all of this block are one of these. Okay, it's kind of a logical view of the indexed allocation. So this is an example of the Unix file system inode structure. Okay, so Unix inode structure use the combination of the index, single is a directory access. Okay, we have the indexed allocation and directory access the data. Double indirect means it's the our index and this is index block access. You can have more. You can make the more number of blocks using triple. Triple is you have one more level, so it's more. What is the difference? If your files are frequently accessed, you can use this one. Otherwise, it's just the data file. Okay, it's so big. At the time, you can use this one. So you can have the combination of that. That is the idea of the inode. This was actually in case of the 32-bit the file pointer address format, you can have actually the representer up to the 4 GB files. Okay, using this inode structure. I still remember one of the final exam question. Prove 4 GB using inode. You can do that. So for example, how many the blocks are used for this, and how many blocks for the single indirect, double indirect, and triple indirect. Then you can calculate how many total size of the file system. So that was the reason. So right now, 64-bit is limited but almost virtually unlimited size of the data. But when you use the 32-bit, the file pointer addressing format in the Linux system, it's limited by 4 GB because of this one. Okay. So in terms of performance, as we discussed before, contiguous the approach is usually the good, okay, but the linked allocation good for the sequential, as you can imagine, but it's not for the random accessing. So most of them is a combination of them I use, like the inode. This slide shows the benchmarking test for the real the system. By the way, what is the MIPS? You should know who knows when you have an interview. So it can be kind of common sense in the IT and computer science. If you ask what is a MIPS?
Million instructions per
Millions
instructions
per second. For what? Performance. The kind of how fast the CPU is and your system is. That you can judge your system performance by counting the millions of instructions.
how many instructions are processed. So if you need more information about the MIPS, you can check this one, the Wikipedia. For example, the Intel Core i7, I didn't do that. I got this one from the Wikipedia. Probably it's 2011, it will be all the information, but in this case, 159,60,000 MIPS is processed. What about the IOPS? Similar thing, input and output, so how many input and output per second. Okay, so benchmarking the criteria for the I/O devices, like the SSD has such a instruction, and hard disk drive has the 250, which means this one is 60,000 IOPS. So this one is much faster. That's the reason the SSD is much faster than the hard disk drive. But nowadays, even hard disk drive manufacturer company, they want to make the faster and faster, the higher the IOPS, the hard disk drive with less the price. So because the people may not realize such a fast the disk, because there are a lot of bottleneck in your system, in your computer system. Sometimes the virus program or the unused service program and the application program. Because of such a program, even though you have a faster device, you cannot get the full benefit of them. Instead, why we need to spend a lot of money for this? If we can have the speed, so we can use such a hard disk drive. I expected the hard disk drive will be gone a couple of years ago, but right now, still that will be used for the general. Okay. So we have such a file system, but I didn't mention. I mentioned about we can find the free block, contiguous block, or the a number of block, but I didn't explain how to manage such a free block. Do you remember that how to manage the free page in the memory management? How can we manage the free pages? We can have the least recently used the page. Okay, so if not has been used or not, we can replace it. This is least recently used. We can have the list of the free pages. Okay, similar approach can be used for the free block management. It's a free space list. So we need only 1 bit. Okay, 1 bit for each logical block. So if we have the 64 block, so we can have a 64 bit. Each block represents 1 means free. 0 means it's the used. So we can have such a list of them. Most of the CPU provide the instruction level, which means hardware level, to find the first available bit 1. Okay? It's not very complicated. You can, using the most significant bit, which one is the largest number. I write some slide there. So very quickly find the first one, the 1. So it's a hardware, because how many the IOs, as you have seen before, it's a huge. The IOs are happened, so for better performance, so the CPU level, the hardware level, instruction level is supported to find the first one from the list. Okay. And also another approach is, so if we know the first the available block, then this one has a link. That is the free, that is the next is the link the free with the list. Okay? What if this one is used? Then header information directory in the superblock directory structure, it will be updated by the pointer will be updated to the here. Then you can keep managing the list of them. What if we have a new, this one is written as a free, then this one will point to this, like that. So this will be used for link to free space list under disk.
discuss of that. And also nowadays some of the file system used something space map used in the GFS in the Linux file system. It takes something map of the entire block, and then it has something data structure, but we are not going to discuss in detail about this. I think that today is the last topic to discuss. So page cache is the tool for better performance in the file system level. So this idea is similar as a page used in the memory management. So let's take a look at this one. This buffer cache is operating system. Is there anyone who attended the defense yesterday? Nobody? So there was a PhD defense yesterday, whose name is Hamud. He actually the defense, he is the research work for the H2H is the head system, something like that. One of the professor asked, his idea is that he'd like to have the own, it's for better performance of the application program, he'd like to have the lookup table on the cache area, memory cache. But one of the professors asked, what if the operating system provides the cache? Why do you use application level cache? That is the operating system level cache. Okay? In the operating system, definitely they use a lot of the cache, the page by page. Okay? So, but file system level, it has also the page cache for the memory map I/O. Do you remember the memory? So memory management, it has a file will be mapped, directly mapped to the memory pages. Then it will speed up to access the data. At the time, it has a page cache. It's a double cache kind of. Do you think a double cache is good for performance? The more cache layer we have, the better? Not always. The problem is hard to manage. What if the data is a buffer cache level, is a page cache level updated, but it's not synchronized? Then when the other non-memory map I/O access of this one, it will be old the data. So it's very hard so it's a good idea in the file system. We can utilize a memory map I/O, so we can utilize a page cache in the memory management. But it causes such a double caching problem. To address that approach, we have the unified buffer cache that includes the system, operating system level cache, as well as the file system at the memory management. The cache is the unified buffer cache to address that one. I'm not going to explain about the recovery. I will introduce a little bit about this next class. Okay, many of the topic in this is discussed in the database also. Okay, log structure. Then we will have the chapter in the next week. Okay. So before we finalize, we have 5 minutes.